So for today's lesson, we're going to look at tensions and pulleys. Now, if you recall, tension is one of those common forces that I talked about, that where a force is exerted by a rope or a string, right? Now, if you think about it, tension forces, because a rope and string is not rigid, that means it's not hard, they can only exert a pulling force, right? So think about your lanyard, for example. You can wrap your lanyard, a lanyard around something and pull, but you can't use that lanyard to push something away, right? So we have to keep that in mind. And since we want to simplify our calculations, we make some assumptions, all right? They may not be necessarily true, but for grade 11, and really most of the time, it makes the calculation much easier. So let's see what these assumptions or simplifications are, okay? So number one, we assume that the strings are massless, so no mass. Now, is that true? Of course not. The strings have mass. But compared to the weights that are hung around them, okay, the strings definitely are much lighter than the mass themselves. The second thing is that the strings do not stretch. That means they're not elastic. Again, technically that's not true, but the amount of stretch that they have is very little, and so we can sort of assume that to be true. And finally, the tension remains constant throughout the string. In other words, that force is the same through the whole string. Okay, so these are the assumptions we make, and we'll see why that's helpful in a minute. All right, so let's take a look at an example and see how this would work. So in this example, two blocks are attached to a rope that is placed around a vertical pulley as shown in this picture. The mass of one block is 3.4 kilograms, so let's call this one 3.4 kilograms. And the mass of the second block is 4.7 kilograms. So we'll say this mass is 4.7 kilograms. And you are asked to find the acceleration and the tension in the string. So what we can see here is we see a pulley right here. So here's the pulley. And so I have two masses just like in our picture. Okay, but these two masses are equal. So you can see that because they're equal, one's not going to be pulled down, all right? They're going to stay balanced. In fact, even if I changed it like this, right, what should happen? Well, because their forces are still equal, their weight is equal, they should still balance. The only time that they would move is if I added another weight like this. So I'll put this on, and now one side is heavier. When I let go, it moves, right? If I were to remove this weight, so let's unhook this. I can here. Doesn't want to be unhooked. Oh. Okay, if I unhook it, it doesn't move anymore. Okay, so this is the pulley system, and so this is what we're trying to figure out. If this one is heavier, how much faster will it accelerate? What's that rate of acceleration? Okay, so the acceleration of the blocks and the tension in the strings. So let's see how we can do that. So if we look at our steps for solving forces questions, the first thing we have to do is draw a free body diagram for each object. So if we take a look, how many objects do we have here? Well, we have two masses, mass 1 and mass 2. So you must draw a free body diagram for mass 1 and a free body diagram for mass 2. So let's take a look at what we have. So for mass 1, what do we have? Well, we have the rope pulling up here, so that's a force of tension, and we have the gravity, Fg, okay, pulling down. Now in this case, to make it to scale, M2 we look here, M2 is heavier. M3 is lighter. So if I look at this, we should see that M1 is going to go flying up and M2 is going to be pulling down. So that's what we should see happening. So that means that the force of gravity here is smaller. And this is the force of gravity of the first mass. On this side, the force of gravity should be bigger and the tension should be smaller. What we've done is we've taken a look at both the objects and said, well, what are the forces? So this block here has a rope and gravity, and this block here also has a rope and gravity, but the direction of the forces, or the length of the forces, is a little bit different. Okay, so that's the first step. Step 2 says establish the direction of motion as positive. So each object will have a different direction of motion. So if you take a look at M1, it goes up, so up is positive. But for M2, it goes down, so down is positive. The next step, cancel out forces that balance. So if I take a look, are there any forces that balance? No. These two forces are different, right? The FT and FG here are different, and the FT and the FG here are different. And there's nothing else I can cancel, so step 3 is done. Step 4 says write out the F-net equation. And you're going to have to write out an F-net equation for each object. So every object that you have a free body diagram for, you have to have an F-net equation for it. That means I have 2 objects, 2 F-net equations. So for this side, F-net is equal to Ft minus Fg1. And that's because this is positive. The Ft for the first mass, the Ft is positive, and the Fg is negative. On this side, F-net is equal to Fg2 minus Ft. So the equation will look a little bit different because the object is moving in a different direction. All right, so now I've set up my F-net equations for both of those. Next step is sub in the known equations. So what equations do we know? Well, I know F-net is equal to MA, so I write MA, but I have to be careful because this is M1A equals Ft minus, my equation for gravity is M1G. For M2, it would be M2A equals M2G minus Ft. I don't have an equation for force of tension. We've never learned an equation for force of tension. So this is all we've got. Next, sub in your known values. So what values do I know? Well, I know M1 is 3.4. So 3.4A is equal to Ft minus 3.4 times 9.8 because I know what G is. And then this one is going to be 4.7A equals 4.7 times 9.8 minus Ft. So then the last step is then to solve, right? So solve, so let's solve it. So this is going to be 3.4A equals Ft minus 3.4 times 9.8 is 33.3. And this side is 4.7A equals 4.7 times 9.8 is 46.1 minus Ft. Okay? So there we are. Now, if I look here, I can't solve this equation by itself because this equation has an A and an Ft. Right? I'll call this equation 1. And this is equation 2, same thing. But they both have A and they both have Ft. So what I should be able to do is I should be able to rearrange one equation. So let me rearrange this one. Ft equals 3.4A plus 33.3. And I should be able to sub this into here. So if I do that, I get 4.7a equals 46.1 minus 3.4a plus 33.3. So 4.7a equals 46.1 minus 3.4a minus 33.3. Okay, so you just got to be careful, right? If it's a negative, that means all of ft is negative. Well, this is, right? This is all of ft. So both of these become negative. So that's why I use the brackets and then multiply through the brackets. If you can do it all in one step, go right ahead. Now you should be able to solve for a without too much difficulty. So go ahead and isolate for a. And hopefully you get a equals 1.58 meters per second squared. And so after sig digs, a is equal to 1.6 meters per second squared. Okay, so we found a. Now remember, we're also asked to find ft. So if we look here, right? So all I have to do is just sub it into one of the equations. So I might as well sub it into equation 1 since I've already isolated for that. So that's 3.4 times 1.58 because we need one extra significant digit plus 33.3. And that gives me 38.67. Therefore, Ft is equal to 39 newtons. And then I'm done. Now, if I did it correctly, I could sub A into here, and I should get the exact same answer. So we can just test it out. Let me just see if it works. So you do 4.7 times 1.6, 46.1 minus Ft. So that means that Ft equals 46.1 minus 7.52, 38.58, or roughly 39 newtons. Okay, so you get the same number. We followed these steps, right? We followed all of our steps in order, and we were able to come up with a solution for what we were looking for. Now, what that means is if I am looking at this particular picture, both of these guys will accelerate at 1.6 meters per second squared, and the tightness in the rope, because the tension in the rope is the same all the way through the rope, then the tightness in this rope is 39 newtons. Okay, so that's essentially what this picture is saying and what we've calculated. Now, if we take a look at a second example, let's see how this is different. So again, two blocks are connected by a string. The mass of the first block is kilograms, and the second is 2 kilograms. Now, this time there is a surface. So if we take a look, there's the surface. So this is what the objects look like. Okay, so this is M1 and this is M2. So we were told M1 is equal to 5.0 kilograms and M2 is equal to 2.0 kilograms. And you may say, Miss, how can something that's only 2 kilograms pull something that is 5 kilograms? Well, because it's resting on a frictionless surface, really there's nothing holding M1 in place. There's nothing holding this on place. So it actually should slide pretty easily. We'll look at what happens with friction in a minute. Okay, so again, the same thing, find the acceleration and the tension. Right, so we want to know acceleration and we want to know the tension. Okay, so now I've written down everything. I don't need my words anymore. This diagram has everything I need to know. So, two objects, two free body diagrams. So free body diagram of M1, free body diagram of M2. Okay, so for M1, what are the forces acting on M1? So again, always have gravity. It's resting on a surface, so there should be a normal force. There's a string pulling this way, so there should be a tension force. And there's no friction, so this is all I have. For the second mass, there's always gravity. And there's also a tension force pulling up. Gravity should probably be bigger here because it's going to fall down. So that's the first step, our free body diagrams. What's the next step? Oh, establish direction of motion as positive. So how would this first block, M1, how would M1 move? Well, M1 would go to the right. So the right becomes positive and the left is negative. Now for M2, how would M2 move? Well, M2 is going to move down. So this is positive and up is negative. All right, so we've done that. Next step, cancel out forces that balance. Well, if I take a look in this case, Fn and Fg balance out, right? Those two are equal, and how do I know that? Again, I know it because M1 and M1 is not moving here in the vertical direction. There's no motion there. And so if it's not moving vertically, the vertical forces right here, these vertical forces must cancel out. All right, for M2, if I look over here, M2, there is nothing that cancels out. Fg is much bigger, Ft is smaller, and there's nothing else. So nothing cancels for M2. All right, next, write out your F net equation. So for M1, it would be F net equals, well, what's left? Right? If I look for M1, the only force that's left is Ft. So that's what F net equals. For M2, F net is equal to Fg, which is the positive one, minus Ft, which is in the negative direction. By the way, I'm getting lazy with my arrows. Don't worry so much about the arrows. Okay? Just know towards the end, most physicists, they understand that, force is a vector, and they just stop writing the arrows. All right? Okay. So now we sub in our equations, if you remember the next step. So this is M1A equals Ft. This is M2A equals M2G minus Ft. Right? So we've done subbed in our known values. Now we subbed in our known equations. Now we sub in our known values. Right? So M1 is 5, so 5A equals Ft. And this one is 2A equals 2 times 9.8 minus Ft. So 2A equals 19.6. All right, now we solve, right? And you just sub in right? And so it's very easy. We don't even have to rearrange for this case. We're going to sub this in directly into equation 2. So right here, so it's going to be 2A equals 19.6 minus 5A, and therefore A equals 2.8 meters per second squared. And again, you should try this on your own to make sure that that's what you get. And that's already in the proper significant digits because both 2 and 5 have 2 significant digits. Now you're also asked to find Ft, so I can plug that into equation 1. It'll be 5 times 2.8 is equal to 14, and that's my Ft. So there's my answers, put my box around it, and I'm done. All right, now we assume that there's no friction in this case, but of course there's always friction. So how would this equation change, or how would this calculation change if there was friction? So it says, what is the acceleration and tension now if the coefficient of kinetic friction is 0.30? So if we look at our free body diagrams, so M1 and the free body diagram of M2, and just keep in mind M2 was 2 kilograms and M1 was 5 kilograms. Okay, what's the free body diagram? Well, this one, let's do M2 first of all, won't change because there's nothing it's rubbing against. So this one stays the same. Okay, for this one, yes, there's gravity. Yes, there's a normal force. There's still that rope, that force of tension applying it. So that stays the same. But now there's also friction force. Hopefully the object still moves to the right. If we get a negative answer, then we know it doesn't. Okay, it doesn't move. But so far, so good. Right? So we've drawn our free body diagram. That's step 1. We've established direction. That's step 2. So now we cancel out forces. These forces again cancel out. Again, remember, this is not always going to be the case, but we're still early in this unit. So right now, cancel out. All right. Now step 4, set up our F net equations. So if I look, it's going to be Ft minus force of friction. And on this side, it'll be F net is equal to Fg minus force of tension. Next step, sub in your known equations. That's going to be M1A equals Ft minus mu Fn. And this is going to be, M2A equals M2G minus Ft. And then here, we also know that in this case, Fn is equal to Fg because they balanced out here, right? And so therefore, this is just mu M1G. Plug in our values, and if you can go directly to this step, go right ahead, right? You don't have to write this every time if you remember sort of what equations you're dealing with. Okay, it's up to you. I'm just writing all the steps so you can see it. So this was 5A equals Ft minus 0.30 times 5 times 9.8. And this is going to be 2A equals 2 times 9.8 minus Ft. Now I'm going to leave you guys to do this on your own. You should be able to do it now. I've plugged all the values in, and hopefully you get A is equal to 0.70 meters per second squared, and Ft equals 18 newtons. Okay, so hopefully you got those two values. So we'll end our lesson here, and I'll see you guys at our next video.